Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss about longest job first scheduling algorithm with an example. So I request everyone to watch the complete video for better understanding. In any scheduling algorithm, we have two important parameters. One is criteria and another one is the mode. First, let me give an overview about the criteria. In a process state diagram, we have 7 states. They are new, ready, running, terminated, wait, suspended wait and suspended ready. When a process which is ready to execute will arrive from the new state to the ready state, we have a ready queue. In a multi-programming system, more than one process can be there in the ready queue. But if you have a single processor, only one process can be executed at any instant of time. Meaning is that only one process can be there in the running state. If you have more than one process which is there in the ready state, now which process you want to dispatch to the running state, that will be decided by the criteria of the scheduling algorithm. If you have first come first served scheduling algorithm, it will consider the arrival time. The process which has arrived first will be dispatched to the running state. If it is shortest job first scheduling algorithm, the process which has the less burst time will be given priority to dispatch to the running state. If it is highest response ratio next scheduling algorithm, the process which has the highest response ratio will be given criteria to schedule to the running state, means the priority. Okay, so when it comes to the longest job first scheduling algorithm, the burst time will be considered as a criteria. The process which has the longest burst time among the process which are there in the ready state will be selected and dispatched to the running state. Okay, so the criteria is burst time. Now you may ask me, sir, what is the meaning of burst time? Look at this one. The process P1 has the burst time is 3 units. So it needs 3 units of CPU time to complete its task. Once it is completed, it will go to the terminated state. Now, we have two types of scheduling algorithms. One is non-preemptive and another one is preemptive. Now, coming to the longest job first scheduling algorithm, it is a non-preemptive scheduling algorithm. Now, what is meant by non-preemptive scheduling algorithm? Once the process has been dispatched to the running state, how much CPU time it needs, that much time will be provided, and once it is done, it will go to the terminated state. Whereas in the preemptive scheduling algorithm, if you look at the one of the preemptive scheduling algorithm is round robin scheduling algorithm, it considers the time quantum. Even the process needs longest CPU burst time, it will be executed only for a specified time quantum. Once the time quantum is expired, the process will be sent to the ready queue. Is it clear? So with this knowledge, let me solve this example using the longest job first scheduling algorithm. To solve any scheduling algorithm, we need to draw the Gantt chart. Always the Gantt chart will start from 0 units of time. We have ready state and we have the running state. Now look at the table and check the each process arrival time. Look at the process P1. It has arrived at 0 units of time. Where it has arrived? It has arrived to the ready state. Any other process has arrived at 0 units of time? No. So only process P1 has arrived. So this process will be dispatched to the running state. Okay. And it needs 3 units of time of the CPU to complete its task. As it is a non-preemptive scheduling algorithm, the total 3 units of time will be provided. Once it is done, it will go to the terminated state. So process P1 has completed. By that time, what are the process has arrived? You need to look at process P2 has arrived and process P3 has arrived to the ready state. Now, if you have two process, which process you can dispatch to the running state depends on the burst time. So look at the each process burst time. P2 has 1 unit of burst time. P3 has 3 units of burst time. As the name suggests, longest job first scheduling algorithm, the process which has the highest or the longest burst time will be given criteria or the priority. So P3 process will be dispatched to the running state. Okay, as it is a non-preemptive scheduling algorithm, it will be executed for 3 units of time. At 6th unit, it will complete its task and will go to the terminated state. By that time, if you look at process P4 also arrived in the ready state. Now, what is its burst time? 2 and P2 is 1 only. Now, which process will be dispatched? Obviously, P4. Okay, so P4 process will be there in the running state and it needs 2 units of CPU time that will be provided. At 8th unit, it will complete its task and will go to the terminated state. Now only one process is there in the ready state, so that will be scheduled to the running state and it needs only 1 unit of CPU time will be provided. At 9th unit, all the processes have completed their tasks. Now with this Gantt chart, we will discuss how can we compute the completion time, turnaround time, waiting time, response time. Okay. So first let me discuss about the completion time. The completion time means at what time the process has completed its tasks and gone to the terminated state. Look at the process P1. It has completed at 3 units of time. Process P3 has completed at 6 units of time. Process P4 completed at 8 units of time. Process P2 has completed at 9 units of time. Now we need to find the turnaround time. The turnaround time will be computed as completion time minus arrival time. Look at the each process completion time and the arrival time. So 3 minus 0 is 3, 9 minus 1 is 8, 6 minus 3 is 3, 8 minus 4 is 4. Okay. Now we need to compute the waiting time. The waiting time will be computed as turnaround time minus burst time. Okay, turnaround time is 3 and burst time is 3, so it is 0. 8 minus 1, 7, 3 minus 3, 0, 4 minus 2, 2. Now we need to compute the response time. As it is a non-preemptive scheduling algorithm, the waiting time will be equal to the response time. However, I will discuss how can you compute the response time. The response time is equal to the time at which the process has entered to the running state minus arrival time. Look at the process P1. It entered to the running state at 0 units of time. Arrival time is also 0. So 0 minus 0 is 0. Look at the process P3. It has entered to the CPU at 3 units of time minus its arrival time is also 3. So 3 minus 3 is 0. Process P4, 6. Arrival time is 4. So 6 minus 4 is 2. Process P2, 8 minus 1, which is 7. So if you look at each process waiting time and response time, they are equal. So if it is a non-preemptive scheduling algorithm, the waiting time will be equal to the response time. If it is a preemptive scheduling algorithm, the waiting time may not be equal to the response time. So I hope you have understood how can you solve the given example for the longest job first scheduling algorithm. Usually in any competitive exams, they will ask you to find the average turnaround time and average waiting time. Now even we will discuss how can we compute the average turnaround time and average waiting time. The average turnaround time is equal to sum of all the process turnaround time by number of process, which is 3 plus 8 plus 3 plus 4 by 4 is equal to 3 plus 8 is 11, 11 plus 3 is 14, 14 plus 4 is 18, okay, by 4, which is equal to 4 4s are 16, okay. So you have 2 by 4 is 0.5. So 4.5 is the average turnaround time for the given question. Similarly, we will discuss how can we compute the average waiting time. Average waiting time is equal to sum of all the process waiting time by number of process, which is 0 plus 7 plus 0 plus 2 by 4, which is equal to 9 by 4, which is 2.25. I hope you have understood how I computed the average turnaround time and average waiting time. If you still have any doubts related to the given example or the concepts which I have discussed, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.